Welcome. My name is Dr. Stephen Herod, and my presentation for you now is a demonstration of the transportation solution of the aggregate plan. Here is the example data for the problem we're going to work on today. On the left, you can see our cost figures for a typical aggregate planning problem, inventory carrying cost, and some pay rates, and some overtime rates, and our hire and fire costs. In this particular problem, some of these numbers will not be relevant. We will not be concerned about hiring and firing in this example, for example, and we will use everything else here. Yes, we will use pretty much everything else in here. We'll use the $8 per unit figure, for example. We won't use the dollars per hour specifically, but we will use the dollars per unit. And then over here, we will definitely use our demand figures. Now, this aggregate planning problem can be formulated as a linear programming problem. It is, in fact, a specific kind of linear programming problem. It is a transportation model, and I encourage you to look at my other sources, my other notes, other references for more detail on that particular explanation, that particular description. But quickly to review, the goal in this problem is to minimize our cost. We are measuring cost in this case as the demand satisfied times the cost per unit, depending on the source used to satisfy that demand. And we'll see in more detail what that means when I actually start formulating the problem on the spreadsheet. We control the production quantities and the time of distribution of those production quantities. And let me explain that here. We control how much we make in each time period. But once we've made that content, once we've made that product in each time period, we have a choice as to when we actually distribute that production. We can distribute it immediately. We can distribute it to customers who are waiting on orders they've already made in the past. That would be a back order fulfillment. Or we may place it into inventory and use it in the future to supply a customer. So not only do we choose how much we're going to make in a particular time period, but what we do with what we've made, there are a number of choices there: back order, immediate fulfillment, inventory. We have some limits in this problem. We have our regular monthly production limits. How much can we make depending on our employee count? And we have our customer demands. What do our customers request from us? We also have some potential limits on overtime and subcontracting in terms of the maximum amount of overtime available and the maximum amount of subcontracting available. But for the interest of simplicity and to move this presentation along, I am not going to specifically put those into this spreadsheet, into this linear programming problem. However, I believe once you've done the model that I present and once you understand that model, adding a limit for overtime or subcontracting should be pretty straightforward. So let's move on and begin the creation of our model on the spreadsheet. Here we have a blank spreadsheet page, and I'm going to begin formatting the initial structure of this model. First, we're going to start out with just our decision variables. Let me put that up here. I'm going to start and put some labels across the top here. Let's go right here, and let's go put a label up there. Let's put this production, and let's put the months in. Okay, there are months. And those are the months of delivery to the customer. So I'm going to center this across the top here, make that look a little nicer. And then over here, here are our months of production. So January, again, we'll just keep doing the same thing all the way across the bottom here. And then let's box this in here. Put a nice box. There we go. Now in this initial problem formulation, we're just going to look at what is the level planning problem. So I'm going to first formulate some basic constraints here. We're going to talk about how much we produce based on the number of employees that we have. So let's put the label regular over here, referring to the fact that this is going to be a decision matrix of regular production figures. And then down here, let's note how much we actually are supplied based on these decisions. I'm going to justify that over there. So this is the sum of everything that I supply to a customer in January and from the sources. And I'll explain that in a little bit more detail here in a minute. Let me put this in. So I'm summing. Each one of these is the sum of the column above it. And for those of you who've seen my prior videos on transportation model or linear programming, I am skipping some of the more basic explanations. You could refer to those videos to see more detail about some of these programming techniques that I'm using. But you can see I'm summing these columns, and I enter the equation once here, and then by dragging across, it copied it automatically across. And that's as much as I'll say on that explanation for the moment. And let's move on. Now let's see. So for each of these months, I have produced, let's put that right here. Let's go across like that. Same thing again. I'm going to total that up. So there are my production totals. And then over here, let's put in our limits for those production totals. Let's go ahead for this initial model. Let's say this is less than or equal to. And then down here, let's say these are equalities. And these are the demands. These are the customer demands. And according to the data set that I showed you in the earlier slide or earlier screenshot, we have 900 demanded this month, 900 demanded that month. I'm just going to go ahead and put these numbers in. So there are our numbers. And now let's scoot over here. Excuse me. Now, we need to calculate what these limits are. We need to calculate, based on the number of employees that I hire, what are the production limits going to be on each of these months right here. Okay, so for each of these limits, we need to have a certain number of employees. So let me put in, and a certain number of production days. So let's go ahead and put that information in over here. We have 22, 18, 21, 21, 22, and 20. Here we go. And then finally over here, let's put in how many employees we have. Widen that column out a little bit. I'm going to color this cell here, give us a little bit of color. So there's our regular employee count. And to speed things up a little bit, I'm going to name that cell. There's our employee count. So the limits here. So from the earlier data, earlier slide, in fact, I'll scoot back over just so you can refresh this information. Here's our example problem data, you remember? And if you take a look here, one employee gives us 5 units per day of production, one full-time employee. So let's go back to our solution here. So this limit right here, in the number of days we have in that month times the number of employees we have times 5. That's how many units we can make in that month, depending on how many employees we choose. So let's scoot that down. Let's fill that formula in all the way down here. So for example, if I have 20 employees, you can see I can produce these different amounts each month based on that production scheme. I'm going to zero that back out again. Okay. So these are now our decision variables, how much we want to produce in each month, and once we make that production, where we're going to send it. So for example, if I decide to produce 100 in the month of February, I could take all of that production in February, and in this example right here, what I've done is I've said I'm going to produce 100 in February, and I'm going to distribute it to customers in March. So I'm saying in that statement, I'm going to hold that material in inventory for 1 month and then distribute it. I could alternatively say I'm going to make 100 in February and distribute them in February, or I could say I'm going to make 50 in February, distribute those in February, and make 50 in February and distribute those in March. So this is a total of 100 manufactured in February, but half of it is going out immediately, and half of it is going out next month. Now I could get even fancier still, and I could say, no, let's do 50, let's do 100, we're going to send out 50 immediately, we're going to use 30 in March, and this gets a little tricky, you have to think about this for a minute, and I'm going to use 20 to distribute to customers for January. Now I want you to just pause and think about that for a minute. I am not actually saying that I can somehow manufacture things in February and then time travel them back to January and distribute them to the customer. What I am saying is that I had promised 20 to the customer in January. I had failed to deliver those in January, but I still have that open obligation that I have not yet filled. That is a back order. And so I'm going to fill that back order by manufacturing at a later time and then shipping it to the customer as a fulfillment of prior promises. So that is what this is. This 20 going to the customer for their January demand from February is stuff shipped in February that is fulfilling prior promises that I have not yet fulfilled. So that's what that means. So I'm going to clear these out now and come down here. Now, these are our decision variables. I've already said that. I have not put costs in here yet. So we do not have a linear program yet because I haven't got any costs, and I do not have an objective function reflecting those costs times the things I control. So let's go down here. Probably the simplest thing for me to do is to just copy this whole structure right here and just make a copy down here. Just put it down here. There we go. So there I just copy that and then rename that. This is now costs. Okay. So let's take a look at what our cost structure would be. For regular production, it will cost me $8 per unit at regular labor wages. That is again coming from, take a look back at our sample data, that's coming from our sample data right there. It costs $8 per unit when I pay people regular labor wages and they're working regular hours, not overtime. So let's come back to the solution. So that's $8. In fact, all of these are cash, so let's go ahead and format this for cash, for currency, for money. So that's $8. If I make them in February and distribute them in February, that's also $8. And it's the same thing all the way down. Now I'm going to highlight these cells like this. These diagonals, these are all the ones that I produce and ship in the same month. So let's just make a note of that. Now, if I produce in January and I ship out in February, I'm holding that in inventory for a month. Now, according to our sample data, and I'm going to go back again to our sample data, we have a $5 per unit per month holding cost. So let's put that into my problem here. So if I make the unit and then hold it for a month before distributing it, I have my $8 production cost plus my $5 holding cost. So my cost here is $13 per unit because I have that additional holding cost. That is my finished cost to the customer. $8 of production plus $5 holding cost. So let's further go down and fill that out. Same thing here, same thing here, same thing here, same thing here. Okay? So in each one of these cases, I'm holding the product for a month, so I have a $5 holding cost. In this month, March, if I make it in January and distribute it in March, I now have 2 months of holding cost. So let's add 2 months of holding cost. So it's $8 production plus $5 for a month plus another $5 for a month. So that is now 18. So let's put that in. So you think you know where we're going from here, so another $5, another $5, another $5, and 28, 28, finally 33. Now, on my spreadsheet, I found it really nice to color code these and see what they look like. So actually, watch this. Let me show you how we want to color code this. A little bit of color, 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 a little bit of color. Let's go to a little darker shade. Let's go another darker shade. Let's go an even darker shade. And then finally our darkest color right there. So what do these colors mean? Well, each color level corresponds to a certain amount of time in inventory. So the darker the color, the more time that item has spent in inventory. So I'm going to kind of make a note of that right here. Now, if this is inventory over here, it might not be too hard for you to then realize that this is then our back orders. So this square right here represents 1 month back order. This is a customer that ordered something for January. We made it in February, and they are getting it a month late. So there's a back order cost, actually. But in this problem, I'm not going to worry about back orders. I don't want to include back orders in my model today. I want to leave that for a future example or for your own experimentation. So if I want to have this in my formulation, but I don't want it to actually happen, I want to zero it out, or I want it to not occur in my model, a really easy way to force the model to disregard back orders is to price these back orders so expensively, make them so expensive that the model would never ever use them because they're so expensive they would be the worst possible choice possible. So for all of these back orders, I'm going to put in an extraordinarily high cost. Just like that. So this model will never use these backorder costs because they're so expensive. It would just be silly. It would just, why do it? There's one too many nines there, but it doesn't really matter. The bottom line is I just want a really large number in these cells so that the model never sees this as a viable choice. Now, if you were to redo this model in the future, and you did want back orders considered, then for each one of these you would need to calculate the per unit cost of production plus the penalty for the back order for that number of months in back order, and that would then be your figure. And I'm going to take the decimals out of this because it's making my columns too wide. Let's take the decimals out. No decimals here, please. Whoops, other way. There we go. And let's tighten up these columns so that you can see everything on your video screen. There we go. I think that's there. Much better. Now you can see everything I'm doing without me having to scroll back and forth on the screen. So I now have a cost structure. I have a decision variable structure. And now the last thing I need is to add an objective. So let's put an objective over here. Highlight that, and let's see, what's a nice color for the objective, guys? What do you think? How about green? Let's put green. And it's too dark. Let's go a little shade lighter. There we go. Maybe that's okay. So our objective is going to be some product, and if you don't know what I'm doing, I encourage you to look at one of my earlier videos or review some earlier notes. This is standard linear programming stuff. So some product are decisions times our costs. There's our objective value right there. Okay, and that's dollars, so let's put a dollar sign on that. Okay. So let's do an initial solution of this problem. Let's do an initial go around with this. Solver. Again, I'm not going to explain how Solver works. My assumption at this point is that this is something you've previously done from an earlier lesson, so I am not going to describe everything I do with Solver. Now our constraint set here, we want our production to be, our total chosen production has to be less than or equal to our derived limits. So we can't exceed our limits of production. And we want our total supplies to the customer to be equal to our demands of the customer. And there we go. And let's set our options. Linear model, non-negative, okay. And let's do a trial solution here. I'm going to solve that now. Okay, something's missing in my model. I've left something out. Let's take a look here. What am I missing? Let's do a little debugging here. That looks good. That looks good. That looks good. Oh, I know what the problem is. I know what the problem is. I left something out. This is a decision variable. These are all decision variables, but we forgot to add employees as a decision variable. Right now I have no employees, and of course the limits are 0, so there's not going to be a solution. So I need to add that into my variable. So the production amounts I control plus I control employees. Let's add that and let's try it again. There we go. Now we got a solution. Okay, there's our solution. Now, we are not really done yet. This is what I call the trivial solution. In fact, I'm going to label that as such down here. Let's label that. Trivial solution. It's trivial because it's still not really realistic. It has a decimal number of employees. We're interested in a level plan with a fixed number of employees. We're not going to hire 0.63 of an employee. We want an integer number. We want either 12, 13, 14, 15, something. We want a whole number of employees. So we now need to modify this a little bit more. So let's now make a copy of this. And let's rename this. This is now our level plan. Okay, so for this level plan, let's try this again. What we need to do now is modify this a little bit. A couple things we need to do. First of all, as a level plan, we need to have all of the employees employed all the time, full time. So here's another problem with this trivial solution. I'm not working my employment staff at their full capacity each month. I am significantly underemploying them. So that's not going to work because I need to have them employed full time. It's a level plan. I can't have them work part-time. I can't tell them to stop coming to work. So these cannot be, these all have to be equalities. So we need to change these to equalities. And again, we want this to be an integer. So we need to revise this. We're going to run this again. I'm going to go solver. I'm going to change this constraint. This has to be an equality now. That's an equality. And now we need to add one more constraint. I need the employees to be integers. I need that to be whole numbers. So let's add another constraint. And we'll change this to integer right there. Integer. Okay. And now we're going to solve that. And there you go. We now have a solution. Now this is what we're really looking for in a level plan. We have a fixed number of employees, a whole number of employees. They are working full-time all the time, so their production matches their limit. And some months we use it all immediately, and other months, like, let's see, where's a good example? Right here. So this month, May, everything we produce goes out the door that same month. But this month, January, the production is distributed out amongst many destinations. A large part of it goes out the door immediately in January, but 100 of it is held in inventory until April, and another 100 is held all the way until June and goes out the door in June. So we have some inventory policies. So if you look at the color coding down here and compare it to the decisions up here, you see we have no back orders. We are not using back orders anywhere as we desired, but we are using inventory. There's inventory in these columns. Here's inventory held here, inventory held here, inventory held here. So there you go. So there is our level plan using inventory, and there's our cost, $58,000 right there. So now before I leave you, I want to try one more variation of this model. I now want to modify this for subcontracting and overtime. If I have the time, I think I can just about find enough time to do this. It's going to be a little bit time consuming, but we can do this. Okay. So let's make another copy of this. Rename this one. Let's call this the subcontract model. Now we want to expand this to include, let's do subcontracting first. Maybe that'll be enough. So let's expand this to support subcontracting. So we need to add a subcontracting cost matrix. So let's do that right here. Let's make a copy of that, put that down here. Call it subcontracting. And I don't want that to squeeze all my alignment out. So let's shorten that name. Subcon, let's abbreviate that. That's good enough. Period. Right there. I don't want to rearrange all of my cells. Okay. So there's our subcontracting right there, and let me put some costs on that. So for subcontracting, if you go back to our data source, here's our subcontracting cost per unit right there. And the same other issues apply. So instead of 8, we're at 10. It changes there, and there, and there, and there, and there. Now there's going to be a holding cost issue with subcontracting too. I'll share a little secret with you. Because of the way we've structured this and because we have not put a limit on subcontracting totals per month, it's not likely, in fact, probably impossible for us to actually have a situation where we make something subcontract and then hold it in inventory. There would have to be some other force causing this to happen, but we'll put the numbers in just to make the model as accurate as possible. So subcontract numbers look like this. Got to add our inventory cost on for any subcontract held in inventory. Okay, so we've got our subcontract costs in. Now let's scoot up here and let's add the subcontract values in. And copy that. Copy. Insert. Shift cells down. Okay, so this is now subcontract. Okay, I'll do the same thing there. That's good enough. There we go. Subcontract. Let's clean all this out here. Zero all that out. Okay. And I'm ready to go, actually. That was pretty speedy quick, wasn't it? Didn't take as long as we thought it would. All right. So now I have my original decision variables for regular production. I've now added some new decision variables that allow me to do subcontracting as a choice. I've added costs for subcontracting. Oh, there's one thing I didn't do. Here, let me show you what else we need to do. Let's scoot these two guys together. Let's delete these cells. Shift cells up. I want to make this one contiguous chunk right here because I need to update my objective function. So the objective function is changing. Let me show you how it's changing, because we need to add all these other new parts into the objective function. So my objective function is now things I control. Here we go. Times costs of things I control. Now notice, oops, we left something out here. Didn't take. Let me try that over again. One more time. Here we go. Things I control. I didn't put the comma in. Comma, the cost of things I control. Here we go. Done. Okay. Now you'll notice I have not included in my objective function the employee count that I control and the cost of that, fundamentally because we have not defined a cost per employee that we have. We have left that out of the equation. We haven't considered this hire fire. It doesn't really work in this model. So the employee count, we're assuming we can choose the number of employees at the beginning of this production plan, and it has no specific cost to us. So that's why the employee count does not appear in this objective function, because there's no cost associated with it. So we control it, but it has no cost, so it's not in the objective function. So we've updated our objective function. So here's our model. I've cleared out these cells. These are our decision variables. I've cleared out their contents to start from scratch. I've zeroed out the number of employees to start from the beginning. Here's our solver dialog. I'm going to clear all this out. Sometimes you get errors. These are left over from the previous worksheet, and sometimes you get errors in these if you start with them already entered from the previous worksheet. So let's clear all this out and then start over. So my objective, minimize this by changing these cells. These are my decision variables, and changing the number of employees. My constraints are that this has to equal this, and this has to equal this, and my employee count has to be an integer, and we've got that. Check my options, they're still set correctly. Solve, and there's my solution. So you see in this solution we have a little bit lower employee count. Let me back up. Let's take a look at the level plan. Remember we had 10 employees and we had a $58,000 solution. Now we added subcontracting as an option. We now are using 8 employees, and we are subcontracting just a little bit in January and a lot more in April and May and June, right there. And so those costs are being incurred, and then we have a much lower total objective, $52,000, $52,480 is our objective function. Now we could expand this to include overtime, and if I wanted to do that, let me show you quickly how we could set that up. Copy here, insert, shift down, overtime. You'd have to update these down here. Copy that over. Let's clear out these results so we can start over. So these are all now those columns. Oops. And then we need to add a cost structure for overtime down here. Make sure that when you add this, the locations of the cells down here match the locations of the cells up here. Okay? Now, I'm not going to take the time to show you what these calculations would be, so I'm going to clear that out. But essentially, you need to repeat these cost calculations the same way that you did them for subcontracting right here. So you put in those costs, fill out those costs right there. We need to update our objective value up here to reflect the new cells. So that is now going to be these guys, comma, times these guys. And once you've got those new cost figures in, then you would open Solver, delete this out, and start over to make sure it's clean and correct. So delete these entries out and start all over again. And you should get another alternative solution depending on the overtime figures. I believe we have an overtime sample data set here. Right there, some overtime numbers. So if you were to take the time to fill all that out, I'll leave that to you for a potential exercise or practice or homework assignment. So thank you very much. I've enjoyed presenting to you this aggregate planning model using linear programming and the transportation network. I look forward to working with you again. Thank you much. This is Dr. Stephen Herod. Goodbye.